Okay, so this is just going to be a quick pencast on reviewing molecular polarity and intermolecular forces of attraction. So again, this is because this is molecular polarity. We are talking only about covalent substances when we're talking about the polarity. All of these dot diagrams that describe molecular polarity will be for covalent substances. So when we're talking about covalent substances, we have two main types of molecules, and for molecules, we use the acronym MSNAP, or MSNAP, for molecules. Symmetrical is nonpolar, asymmetrical is polar. So for a symmetrical nonpolar molecule, there will be an even distribution of charge throughout the molecule, and the shape will be symmetrical. For an asymmetrical polar molecule, there will be an uneven distribution of charge, which means that there will be a positive end to the molecule and a negative end to the molecule. Those will be determined by electronegativity. Higher electronegativity will give the side where that element is the negative charge. For some examples, when we're talking about, for example, H2, hydrogen bonded with another hydrogen atom, that has a nonpolar covalent bond because it's two atoms of the same nonmetal. And it is also a nonpolar symmetrical molecule, so the charge is evenly distributed. For a molecule such as HCl, where the H is single bonded to the Cl, that has a polar covalent bond. The electrons are shared unevenly between two different atoms of two different nonmetals. It is also a polar asymmetrical molecule, which means we have to look up electronegativities to find out the positive side and the negative side. Chlorine has a higher electronegativity, so it will get the partial negative. Hydrogen has a lower electronegativity, so it will get the partial positive. That little squiggly is a delta. You can omit the delta if you choose to, but the positive and the negatives need to be there. For water, H2O, we have a bent shape. We have polar covalent bonds between both of the hydrogens and the oxygen. Those polar covalent bonds share the electrons unevenly. We also have a polar asymmetrical molecule, and since oxygen has a higher electronegativity, it gets the negative. Since hydrogen has the lower electronegativity, that side gets the positive. For methane, which is CH4, we have polar covalent bonds sharing electrons unequally between atoms of different nonmetals, but it is an overall nonpolar molecule because the shape is symmetrical, which means there is not a positive side or a negative side. The charges are distributed evenly. Based on the molecular shapes, we will have different dominant types of intermolecular forces of attraction. The first type, which is present actually in all types of molecules, is called the van der Waals forces or the dispersion forces. Those are weak forces present in all types of molecules, but it happens to be the only kind of force present in nonpolars. Those nonpolar molecules tend to have low boiling points. Dispersion and van der Waals forces increase with more electrons in the molecule, which is why we see an increase in boiling point as we go down group 17 on the periodic table. Second intermolecular force, which exists between molecules of polar substances, is dipole-dipole forces, where the positive side of one molecule attracts the negative side of a different molecule. These partial charges allow the molecules to have a tighter connection or a stronger force of attraction, which means that dipole-dipole forces generally cause higher boiling points than dispersion forces alone. Hydrogen bonding is a special, stronger type of dipole-dipole force. It accounts for the higher than expected boiling points of NH3, H2O, and hydrogen fluoride. And again, even though it's called hydrogen bonding, it is not a bond. It is an intermolecular force of attraction. And then finally, stuck in here is molecule ion attraction, which exists in all aqueous solutions for ionic substances. So anytime you have an aqueous, an ionic formula with AQ after it, remember that means dissolved in water. The ions from the ionic substance attract the molecules of the water, so that the positive metal ion attracts the negative side of the water, which would be the oxygen side. The negative nonmetal ion attracts the positive side of the water, which would be the hydrogen side. And the water molecules surround the ions so that positives and negatives are interacting with each other.